Okay, let's look at more examples of integration by substitution. Right. So it's nice to know what to substitute. So here's a couple examples. Right. So when you have an integral involving natural log of x, and the natural log of x is generally very difficult to deal with in terms of taking an antiderivative. So it's a good idea to get rid of it. So we're gonna do substitution. So we're gonna let u be natural log of x, right? Then you can kind of check to see if it's the right substitution in your head. Yeah, take the derivative of your choice of u, and you can see that derivative of natural log of x is 1 over x. And you can see that the 1 over x is a part of the integrand. And that's an indication of you have the, probably the right substitution, right? So in this case, it's going to probably work out, right? So take the derivative. So go through the usual drill, right? Take the derivative of u with respect to x, right? So we get 1 over x, right? And take the reciprocal of both sides. So I'll write it as raise it to the 1/2 power. So you have a dx over du is equal to reciprocal of 1 over x is x, right? And the last step is we're going to multiply both sides by du so that we can isolate dx all by itself. So you have x du, right? So let's go through the substitution, right? So we decided to call this guy right here u, right? So you will have so this is going to be equal to, so you have an integral, right? So on top you have a u, then you have to square that, u squared, over, right? I'm going to leave x as it is for now, right? And the dx is same as, so you can see that the dx is same as x du, right? So you can put that guy in here. So x, right, du, right? So you can see that here you have x on the bottom and x on the bottom, on top. They cancel out, right? So you have to be able to get rid of all the x's since we're rewriting the integral in terms of this new variable u, right? So you cannot have x left over there. All right, so clean it up a bit. So this is just going to be integral of u squared du, right? So this is just going to be a power rule. So we have add 1 to the power, so u cubed, divided by that power, so over 3. And then you have a plus some constant c, right? And this is equal to, right, u is originally natural log of x. So we're going to have to put that back in. So natural log of x, raise it to the 3rd power over 3 plus some constant c, right? So that is our final answer, right? So we have that. So remember that if the integrand has a natural log of x, there's a pretty good chance that the u is going to be natural log of x, right? Let's look at the next example, right? So you have an integral 1x over square root of x minus 3 dx, right? So in terms of finding the antiderivative, we would like to have a simpler denominator than maybe more complicated numerator, rather than complicated denominator with a simple numerator, right? So our motivation is to simplify this denominator, right? So we're gonna use a substitution, and also there's a square root there. So we're gonna let u be x minus 3. Right? Then if you take the derivative, you will find something troublesome. Hey, du over dx is actually just 1. All right, and which means that du and dx are actually identical. So multiply by dx. Right, so we can interchange du and dx. Right, so when you do that, you're gonna get this. So you have an integral, right? Then you have we decided to call x minus 3 u. So you have square root of u on the bottom, right? And a dx is just the same as du, so we can put du instead of dx. Right, then you have this x left over, right? There's nothing to cancel x, right? So what we need to do is we're going to actually rewrite the substitution equation, then solve for x. So we can just add 3 to both sides. So you can see that the u plus 3 is actually exactly the same thing as x, right? So instead of canceling them out, we actually rewrite x as u plus 3. So we put u plus 3, right? So this is good because we got rid of all the x's and everything is written in terms of u, right? So then we need to simplify this, right? So we have square root of x, u, and we don't like square root, so I'm going to write it as u to the 1/2 power, right? Then you have a couple of fractions, so we're going to split into 2 fractions here. First guy is u over square root of u, right? So let's write that. So this is going to be equal to integral, right? U divided by square u to the 1/2 would be 1 minus 1/2, so u to the 1/2 power, right? Then you have a plus sign here, so I'm going to put a plus sign here, right? Then 3 is there, right? Then you have you can see that the 3 over square root of u. So I don't like having a denominator, so I'm going to write it as u, right? Since u is sitting on the bottom, so it's going to be a negative power, and square root is 1/2 power. So we can rewrite this integrand this way. All right, now this is just a power rule, so go ahead and apply the power rule. So this is equal to, right, add 1 to the power, so you have u to the 3/2 power, right, divided by 3/2 is equivalent to multiply by 2/3, right? And you have plus 3, right? Then we add 1 to the power, so you have a u to the, right, 1/2 plus 1 is positive 1/2, sorry, negative 1/2 plus 1 is positive 1/2, right? Dividing by 1/2 is equivalent to multiply by 2, right? Then you have some constant c, so plus constant c. Right, then let's clean it up and plug in the original variable back in, expression back in. So this is going to be equal to, right, so you have a 2/3, right? U is x minus 3, so quantity x minus 3 raised to the 3/2 power, and plus, right, 3 times 2 is 6. Then u is quantity x minus 3, and raise it to the 1/2. So you can write it as square root if you want. And then you have a plus some constant c, right? So this is the final answer for the second example. All right, that's it. I hope that this was clear.